Hello, my name is Emily Sargent. Today I'll be presenting a philosophical theory of physics that represents a paradigm shift with regards to the fundamentality of consciousness. I will outline a monist view of the universe where consciousness is fundamental reality existing as a one-dimensional, non-physical singularity, and our physical universe emerges from this in its entirety. The singularity creates and encodes a conformal field theory on a two-dimensional boundary, which is dual to spacetime in a higher dimension, as the ADS-CFT correspondence postulates. I will also posit that all eons in the conformal cyclic cosmology model exist simultaneously in a four-dimensional hyperspace, despite occurring in succession in the reality we observe, and I will examine its geometric structure. As my theory is philosophical in nature, I will focus on the logic that may connect disparate threads in physics and formulate an outline for further study. I must also note this theory contains highly speculative concepts that are currently at the forefront of theoretical physics and consciousness studies, but I will show how they may converge in a logically coherent framework. To start, it is necessary to explore holography and the ADS-CFT correspondence. Holography is a technique that allows us to construct a higher dimensional object through encoding the information in one lower dimension. Simply, the holographic principle maintains that all of the information about a volume of space is encoded on its boundary. In ADS-CFT correspondence, anti-de Sitter spacetime is dual to a conformal field theory on the 2D boundary of the ADS bulk spacetime. A CFT is a quantum field theory that is invariant under conformal transformations, meaning all internal angles stay the same regardless of size, much like zooming in and out on your phone screen. The degrees of freedom, the number of possible states of this conformal field theory, are entangled with each other, and this gives rise to the geometry of spacetime, meaning gravity is emergent and arises from the boundary. The ADS-CFT correspondence therefore postulates that a model of quantum gravity in anti-de Sitter space, the bulk spacetime, is dual to a conformal field theory in one dimension lower at the boundary to the bulk. The holographic principle that is central to this theory and the knowledge that gravity may be emergent in nature coincides with the connections being probed through black holes and the interplay of gravity and thermodynamics, which also suggests gravity may be an emergent entropic phenomenon rather than a fundamental force. This means we can examine the special case of black holes to learn more about the ADS-CFT duality. Research surrounding black holes led to the development of Bekenstein-Hawking entropy, which relates the entropy of a black hole to its surface area, showing that entropy is proportional to the area of the event horizon of the black hole. This relates the gravitational entropy to the degeneracy of the quantum field theory as a microscopic description. This degeneracy is the existence of multiple states with the same discrete energy levels, and this relationship between gravitational entropy and the degeneracy of the quantum field theory shows the entropy of the system is proportional to the logarithm of the number of possible states it can be in. The entropy of black holes can be derived microscopically by counting the number of microscopic states associated with the black hole event horizon by using the conformal field theory to count these. We find from this that the black holes are not empty, but rather contain a vast number of microscopic degrees of freedom, which are responsible for the entropy of the black hole, and these are mapped to the degrees of freedom of the conformal field theory on the boundary, making Bekenstein-Hawking entropy proportional to the von Neumann entropy of the conformal field theory boundary. This provides us with a special example of the ADS-CFT duality and shows the importance of entanglement in our understanding. However, we still require a more comprehensive gravitational interpretation of entanglement entropy, which can be proposed in light of the ADS-CFT correspondence. We can use an area law which allows us to anchor a mathematical object called the minimal surface in the ADS spacetime to the boundary where the CFT is encoded. The minimal surface will only take into account the degrees of freedom of the CFT relevant to the entanglement entropy and can be thought of as a holographic screen, allowing us to calculate the entanglement entropy of subsystem A in the CFT using the area of the minimal surface in ADS as the geodesic boundary. It is analogous to the event horizon of B as though B were a black hole, although the division of A and B is just artificial. The observer in ADS space is not accessible to the 2D boundary and will probe the minimal surface in the bulk that it is anchored to as a holographic screen, as opposed to the boundary itself, allowing for a possible gravitational interpretation of entanglement entropy that works with the degrees of freedom of the CFT, the entanglement of which leads to quantum gravity. Therefore, a lower dimensional CFT on a boundary is dual through holography to a spacetime in one higher dimension, as the entanglement between CFT degrees of freedom at the boundary determines the ways particles interact and leads to the geometry of spacetime, so that the more entangled the degrees of freedom are, the stronger their correlations and the more curved spacetime becomes, thus the higher the strength of gravity is. Entanglement allows information about bulk spacetime to be encoded on the boundary, and the two-way nature of entanglement between the degrees of freedom of the boundary and the bulk is what leads to the geometry of spacetime, making entanglement fundamental. Furthermore, as entanglement is fundamental to this relationship, we see how following ER-EPR conjecture, we will see how a network of wormholes is also fundamental and the counterpart to quantum entanglement within the theory of general relativity. The ADS-CFT duality is therefore a useful tool for combining general relativity and quantum mechanics to create a quantum gravity framework. We also see how spacetime is built through entanglement, as the emergence of spacetime is intimately connected to the entanglement of the degrees of freedom in quantum gravity, where we will find that if we disentangle the degrees of freedom, regions of space will pull apart and pinch off in a way that is quantifiable with standard measures of entanglement. We also note that through this correspondence, each different quantum state of the CFT corresponds to a different spacetime in the bulk, and thus a different possible universe marked by a different way gravity manifests itself, thanks to the state of the CFT on the boundary, encoding all of the information about the asymptotics of spacetime and thus the quantum gravity. The duality is elucidated further by understanding that it is the operators that comprise the quantum states of the CFT, each state having a unique set of operators that describe it, which are entangled, and these operators have a corresponding particle nature in the bulk spacetime. The operators and particles being the building blocks of their respective environments. Therefore, a gluon would have a particle nature existing in the bulk and a corresponding operator nature existing in the CFT on the boundary. Fermions and bosons all work in this way, and we can take this to suggest that the discreteness at small distances in spacetime is a manifestation of the holographic nature of spacetime and highlights the fundamental role entanglement plays in the duality. ER equals EPR conjecture suggests that between entangled states there will be an ER bridge, which is a wormhole. This posits an intimate connection between gravity and quantum mechanics, which can be studied through black holes, as these objects are both highly gravitational and quantum mechanical, allowing us to probe the connection further and see how quantum mechanics may be encoded in space-time geometry. We know quantum mechanics gives rise to EPR correlations, and general relativity allows for ER bridge solutions to the equations of motion, which enable a connection of far apart regions of space-time through a wormhole. Therefore, two entangled black holes will also have an ER bridge between the microstates of the black holes. This is useful in resolving paradoxes that plague our understanding of black holes, as information can be encoded by an ER bridge mechanism and retrieved through Hawking radiation, providing a resolution to the black hole information paradox. And we will see that the AMPS paradox can also be resolved using ER equals EPR. It's possible to have two entangled black holes by construction. Moreover, if you arbitrarily cut spacetime in half and create a lattice of cells, you will find that each cell is entangled with another in a specific pattern. For example, at the boundary, the corresponding cells immediate to either side of the boundary would be entangled, and we see a pattern of entanglement that builds the structure of spacetime. If we make a measurement in one of the regions of spacetime, we find that the region it's entangled with will contain a virtual particle if the first cell does, and will not contain a virtual particle if the first cell does not. Taking this point that spacetime is entangled in conjunction with the fact two black holes can be entangled, we run into a potential issue. The event horizons of black holes are considered to be smooth space-like regions where nothing out of the ordinary would happen, meaning if spacetime is entangled in a pattern, a point of spacetime at the exterior of a smooth boundary would be entangled with a point of spacetime in the interior of the black hole. This causes major problems when taken in conjunction with the fact two black holes can be entangled with each other, as there is a principle of monogamy in quantum mechanics that states anything can only be maximally entangled with one other entity. This is the foundation for the AMPS paradox. When a black hole is entangled with another, but should also have entanglement between one region inside the black hole and a region of spacetime at its exterior, this cannot occur due to monogamy. This led to the suggestion of a firewall occurring, which would mean the interior of a black hole is wiped out, which is unsatisfactory for a number of reasons. However, ER bridges can provide a solution to the paradox. An ER bridge between the black holes with a singularity at its centre would allow us to send the signal into either black hole, and though we can't expect it to reach the exterior of the other, it can reach the interior of black hole B, showing they're connected through this ER bridge, resolving the issues with firewalls. Destruction of entanglement of spacetime in the quantum theory should on this basis then be mirrored by a change in curvature in the gravitational theory, and as the energy required to make the measurement destroying the entanglement will have a gravitational effect, this will alter the curvature of spacetime at that position, highlighting how ER equals EPR together zip up the structure of spacetime. Thus, the holographic principle can be used to argue that the entanglement entropy of an EPR entangled pair is proportional to the area of the wormhole that connects them, because the entanglement entropy is a measure of the amount of information shared between the pair, and the wormhole is a measure of the amount of information encoded on its boundary. Interestingly, any entangled state in a superposition of states should involve ER bridges between them, which have a singularity at the centre. Understanding this may show how this accounts for our experience of consciousness, as ER bridges between entangled entities allow us access to the consciousness singularity at the centre of the bridge, and upon collapse of the wave function, the outcome is selected from all the possible states in the superposition by the consciousness singularity we access through an ER. These moments of proto-consciousness are the building blocks of our complex conscious experience, as we have many of these moments occurring within our brains potentially. However, even particles, for example, will have a primitive version of what we experience upon objective reduction. For this model, it's necessary to explain a mechanism for the collapse of a wave function, which leads us to gravitational objective reduction. This is an interpretation of quantum mechanics that proposes the wave function of a quantum system collapses when it interacts with gravity. It proposes that all possible outcomes, each possible state in the superposition, are real, but the wave function collapses and only one occurs. Without this, we would see all the states in the superposition occurring in our universe, which would be very different to the reality we know. This means either collapse of the wave function or branching of the universe occurs. Using gravitational objective reduction, we find that a quantum system in a superposition of states will eventually face collapse of the superposition when the separation between the states reaches a critical threshold, which is determined by the strength of the gravitational field and the mass of the quantum system. When the wave function collapses, selection of one of the possible states occurs and the other states are lost. In the double slit experiment, then, it is the gravitational field of the observer that collapses the wave function, as the observer has a mass which deforms spacetime, warping it, and this then causes the separation between states in the superposition to reach the threshold, and an outcome gets selected, dismantling entanglement and the ER bridge. This is a valid interpretation of quantum mechanics, but alone provides no resolution to the measurement problem, which is the issue of how to reconcile the wave function's probabilistic nature with the fact that the measurements always yield definite results. This is where orchestrated objective reduction theory of consciousness comes in. Penrose and Hameroff posit that at the moment the threshold is reached, we get a spark of proto-consciousness. Gravitational objective reduction would mean wave function collapses are very common in the universe and happening often, producing this proto-consciousness that has a fundamental involvement in the reduction of superpositions to classical reality. I posit that this proto-consciousness is what selects the outcome and thus plays a key role in Planck scale geometry and could be important to basic physics such as mass, spin and charges. As mentioned, this proto-consciousness is the basis for consciousness in the human brain, and to reconcile this, we would need to show that the brain can act as a quantum computer. Critics suggest the brain may be too wet and moist, but Hameroff and Penrose present reason to believe it's possible. In 2006, it was found that plants use quantum coherence in photosynthesis, and the arrangements involved were similar to arrangements of tubulin found in microtubules in the brain. Microtubules are highly symmetrical objects that potentially have an ability to allow quantum coherence to be preserved for long enough that gravitational objective reduction of the state could occur, and qubits in the microtubules can be in the superposition, thus maintaining entanglement to the degree required. Microtubules would therefore be responsible for quantum computing in the brain, and that consciousness may have a fundamental involvement in the operation of physical laws, linking it to the fine-scale structure of space-time geometry. This also leaves a pathway for preserving free will in the theory as proto-consciousness arises through access to the consciousness singularity via ER bridges, allowing for our subjective experience and providing a mechanism to make a genuine choice of outcome. Experimentally, a gravitational field has been found to affect the collapse of a wave function in a small system, but it must now be extended to see whether this works for a larger system like the brain. We also see larger objects will reach the threshold for objective reduction quicker, meaning Schrödinger's cat in the famous thought experiment would find an outcome in a time less than the Planck scale, but electrons in superpositions may take thousands of years to reach the threshold, but could reach this threshold if an observer's gravitational field disturbed it. In addition, microtubules have been shown to be affected by anesthetics, which of course are known to have a profound effect on our experience of consciousness, laying some support to this idea. Therefore, I've now presented the way the model of the universe is composed, but we must recover the standard model and account for everything we observe, which I will attempt to show could be possible through a combined approach. String theory and loop quantum gravity have long been seen as incompatible, but it seems this may not be the case. Though string theory requires at least 10 dimensions, and the two theories seem to describe different things, a contact point may arise between the theories through ADS-CFT duality, as strings need not play a role in this theory, but special relativity necessitates interactions similar to those in string theory, whilst ADS-CFT correspondence describes spacetime as arising from a network, much like the one posited by loop quantum gravity. We can use spin foam models, which are two-dimensional, piecewise linear complexes with a finite collection of polygons attached along their edges, to mathematically formulate loop quantum gravity. The faces of the polygons in the finite collection are labelled by spins and their edges by intertwining operators. One spin foam network each corresponds to one possible universe, and while spin foams are just mathematical objects, we can use them to describe the quantum state of spacetime in loop quantum gravity. And as spin foams are made of tiny loops, this is compatible with ER-EPR conjecture. The nodes contain the possible spacetime states, and the links encode transitions between states and show how ER bridges provide a physical explanation for how entanglement works. The mathematical model of spin foams allows each finite collection of polygons corresponding to a possible universe to fit into an infinite permutahedron geometric structure, encapsulating all the possible universes through geometry, which may describe a four-dimensional hyperspace where each possible universe exists simultaneously. I will discuss in a moment how each possible universe is a different eon in the conformal cyclic cosmology model, but it's interesting to note that the infinite permutahedron is closely related to the amplituhedron, offering an explanation as to why the amplituhedron has been used to easily calculate scattering amplitudes, vastly simplifying our calculations in quantum mechanics and allowing scattering amplitudes to be derived without unitarity and locality. N equals 4 supersymmetric Yang-Mills theory is dual to string theory and works with ADS-CFT correspondence, and this could be a candidate for modification to fit with the spin foam formulation of loop quantum gravity. We can build the mathematical framework for CFT operators and their correlation functions calculated using the conformal bootstrap method or an improved theory eventually, allowing us to relate correlation functions of CFT operators to the gravitational degrees of freedom in the bulk, and then relate each to a corresponding spin foam formulation, and take each spin foam and its spin foam amplitude and get their corresponding tensor networks through coarse graining. Following this method instead of using a path integral formulation will make the theory generally covariant, Lorentz invariant, conformally invariant and compatible with ER-EPR and holography, and may provide us with a promising theory of quantum gravity and help confirm ADS-CFT duality and loop quantum gravity. Moreover, ER=EPR may be able to explain dark energy and the cosmological constant through vacuum energy fluctuations, which, although seemingly may go against the idea of a constant energy density of the vacuum, which experiences no dilution upon expansion of spacetime, it does not, as I will show. To see what the universe does in its entirety, we need a scale factor as a function of time. If the universe expands, then the scale factor increases, and the acceleration of expansion will have a contribution proportional to the cosmological constant, making the expansion speed up. If the cosmological constant is due to fluctuations in the vacuum, why is it constant then? Quantum fluctuations and their mathematical representations as virtual particles can be responsible for the cosmological constant if virtual particles are confined inside ER bridges that connect different points in spacetime. The negative pressure of virtual particles would not necessarily be enough to account for dark energy alone, but could be enough if they're confined within ER bridges, causing the ER bridges to expand over time, which we see through the fact we know their length is proportional to time. The expansion of ER bridges would then be the actual expansion of spacetime over time, and the negative pressure of virtual particles could counteract the inward pull of gravity in ER bridges, and the expansion of bridges would be constant, so explaining how the cosmological constant is constant. The growth of the ER bridge, proportional to time, can also be accounted for by the growth of quantum complexity, meaning in a dual theory combining general relativity and quantum mechanics, the growth can be thought of as both an increase in length of the bridge and increase in quantum complexity over time, and quantum complexity in virtual particles can be thought of as aspects of some underlying phenomenon. Why then do quantum fields throughout spacetime fluctuate rather than just stay the same? This is because of the uncertainty principle, and if spacetime is made of entanglement and wormholes, then it explains why it should be governed by the uncertainty principle, because it is not just emptiness. The geometry of spacetime coming from entanglement of operators in the CFT at the boundary means entanglement of these would lead to ER bridges in spacetime connecting it into a structure. The nodes in loop quantum gravity would therefore be the points where ER bridges boundaries are. In spin foam models, then, the links of spacetime are ER bridges and the nodes of spacetime are the boundaries of ER bridges, meaning their nodes would be extended objects as the boundary cannot be separated from the links and the boundary is not point-like. Spacetime would be granular due to the network, and the nodes in spin foam models being boundaries of ER bridges being extended objects may mean we do not need string theory, as this set out to explain that the building blocks of the universe need to be extended objects due to things not having a point-like nature, but with ER=EPR and loop quantum gravity, we can explain spacetime this way without the need for extra dimensions, and the ADS-CFT duality can then explain particles without a need for strings and extra dimensions as well. We can now be left to discuss the infinite permutahedron geometry that may describe a four-dimensional hyperspace that contains a network of all spin frames, each corresponding to a possible universe. These possibilities being defined by the eons in conformal cyclic cosmology. Confined into one geometric structure, embedded in hyperspace. These eons occur in succession in our three-dimensional plus time reality, but may exist simultaneously in a hyperspace. Currently, we see the universe expanding exponentially, and this will continue into the very remote future, leaving us with just photons, which are of course massless, meaning they do not experience time or have a measure of scale of the universe. The rest massive particles become irrelevant at the Big Bang due to high temperatures and densities, and they too do not experience the passage of time or have any sense of scale. There's nothing, therefore, to distinguish the size of the universe in these situations, and due to conformal invariance, the initial state of the universe and the remote future are the same physically. As a boundary to spacetime at infinity is spacelike to a photon who can reach infinity, photons can pass through or step over the boundary heading into the next eon, which will begin with a Big Bang where conditions are as shown, physically the same as the remote future they left. This model then resolves issues with the graceful exit of the inflationary period, as this would have happened before the Big Bang, in the exponential expansion of the remote future of the previous eon. To test this and provide evidence for the theory, we should detect gravitational waves and halting points, which are areas with increased temperature in comparison to their surroundings, in CMB. As gravitational waves and electromagnetic radiation have no mass, they can pass through the boundary into the next eon. We've detected halting points with 99.98% accuracy, lending support to the theory. The singularity at the Big Bang, according to the Wahl curvature hypothesis, states that the non-activation of gravitational degrees of freedom at the Big Bang would mean the singularity would be constrained to have a Wahl curvature of 0, and suggests the singularity here is a mathematical artifact. Conversely, singularities in black holes are not constrained in this way and can have infinite curvature, meaning they are real, which is required for our model that posits that the singularity is the consciousness realm.